Hello everyone, welcome to my channel, and we have a new circuits here. Let us see the circuits here. We have 5 circuits here, and we're trying to find out where is the NAND gates here. And these are 5 circuits here. We have 5 circuits here. So let us see the circuit of these 5 circuits. We have here circuit 1, circuit 2, 3, 4, 5, and let us see the circuit of each one. The circuit of this one is this: transistor, switch, buffer, gate. This is the circuit diagram. We have 5 volt supply here, transistor, resistor, 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 push button. This is the circuit diagram. We have the output here, the LED, the green one, and then we have a resistor here to protect the LED, resistor here to bias the transistor and to prevent leakage current, and we have here resistor to protect the transistor and resistor to pull down the push button in order not to hang the push button here. And we have the layout here, and we calculated all the values here because this is our previous circuit: transistor, switch, buffer, gate. And there's no leakage current here. Let us see the circuit of this the second one. It seems that LED is turning on. We have a push button here, a resistor, transistor, LED, perf board, and the circuit of that one is transistor, logic gates, inverter. So this is the circuit diagram. The LED is connected to the connector and to the ground. We have transistor here, resistor, 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 supply volts, 12 volts, push button. So in here, the operation here is the transistor is using as a switch in saturation mode. When you close the switch here, there's no switch here, but when you close the circuit here, nothing flows here. The current flows, there's no current flows here. Once you push the button, current flows here to the collector, to the transistor, to the emitter, and then also here to the base, to the emitter, conducting a transistor in saturation mode. And also here, we calculated all the values here, and so this circuit is can be operated by pushing the button here. But since this is a buffer gate, according to the truth table, no input, no output here. If you don't push the button here, output is 0, input is 0, output is 0. Push the button, transistor conducts in saturation mode. So we have no input here yet, that's why there's no output. In here, the transistor is also as a switch. The LED is connected across the collector and the emitter. So if you have a closed circuit here, the supply goes here, stops here. This is open line, and also here, but stops here at the transistor because there's no base current here. Transistor is off, and then current travels to the LED. That's why there is a closed circuit here. Then since this is inverter, the truth table of an inverter is no input but with output. But when you have an input, the LED turns up. It means there's no output. And here is the circuit diagram, the parts, and then the layout. This is our previous circuit, and this is the previous circuit, an inverter, this one. And we have here this one. Seems a lot of resistors here, and transparent LED, very nice. Push button, two input, and that is transistor or gate. And this is a very that is a previous circuit also. Transistor is facing each other in this manner. Push button is here, also here. Resistor, transistor, resistor at the base. LED, the output LED is taken here at the emitter side of the resistor. And we have also a resistor here, bias resistor here, LED protector, resistor, LED protector, resistor, base resistor protecting the transistor, base resistor protecting the transistor, push button here. Voltage supply 12 volts, and this is the layout. This is a previous circuit also. And here's the truth table of an OR gate. No input with the two switch here or two input here. It means there is no output. When there's an input in one of the switch, when you push the button, when you push the switch in either one of the two, we have an output. Here, when you push the switch A, we have output. If you push both the switch, we have output. That is the operation of the OR gate, and that is the circuit here. Now, where is the NAND gate here? Let us see the circuit of this one. This is also two push button, two input LED, and one output LED transistor, resistor, some LED power on, lights here. And the circuit of this one is this NAND gate, transistor, NAND gate, NPN. Two transistor is connected in this design. Push button is there, the push button is there, base resistor, LED, the connected to the switch, LED connected to the switch, that is the LED, the red connected to the switch. And we have this bias resistor and also a resistor here to eliminate some sort of leakage current, pull down resistor. At the same time, protector of the LED here. The resistor here is the LED, that is the LED power on indicator, that is the blue one. And we calculated also the values of all the resistor here, and we have the given here, the given data, the data sheet of the transistor. Also we have calculation here, and we have the layout, pin configuration, and we have the truth table of the AND gate. Switch A, switch B, this one is to, if there's no input, there's no output. When you push switch B, there's still no output. Switch A, still no output. If you both push the switch or with input, there's an input. It means you need to push both the button to make an output. And that is the layout here, the transistor and gate. And this one is the layout, the circuit diagram, the parts here. And then we have the circuit here. This one, the blue LED power on. And we can just quick review of the current flows here. When you close the circuit, the only lighting is LED here, that is the blue, and then two push buttons. Still the transistor is open. When you push the button here, current flows here. The collector only here, and not lighting the LED because the transistor is off even without this resistor, because the LED current rating is 0.02, and there's a resistance here making the LED to turn off even there's current flows here because of the big resistance here. So when you push again the second button, current flows here but not flows here, so there's no current flows here because of the open push button here, open circuit here. Transistor is off. When you push both the button here, current flows here directly to the ground. And the use of this one is a bias resistor, and this one is to prevent the leakage current. And so that is the operation of the AND gate. And this is our new circuit. This is a NAND gate, and the circuit of this one is this. Let us see the circuit of this one. This is the circuit, and the light is very. So this is transistor NAND gate using the same transistor configuration, and we got here yellow LED power on, LED blue input LED for the switch, and this is the circuit diagram. We have the given here, the HIP, IC, BCE, and we calculated the values here now using Kirchhoff's voltage law. Here, when you close the circuit, only the lighting here is the LED yellow because the transistor is off. Both the transistors are off. Due to the push button here is open, so when you push the button here, current flows here. And as you see, this is NAND gate, and the truth table is, you see that LED is still lighting. It means if you don't have an output here, still LED turns on. You have an input of 1. If you push the button here, still 1, output 1, and when you push the button is still 1. If you both push the button, the LED turns off for an output of 0. So this is normally turns on because according to the truth table, 0, no output, still LED turns on, input 1. So we calculated all the values here using Kirchhoff's. So in here, when you push the button here, still the LED turns on because the current flows directly to the LED. Where LED is pull up or sourcing current here. So the LED is still conducting. When you push the other button, still LED is conducting here. LED is turning on. When you push both the button here, the LED will turn off because the current flows here, short-circuiting the transistor and making the LED off. We can see that in our demonstration after this one. So these are the final circuit with its corresponding values. I'm using 12 volts design, but it works on 5 volts. That is the layout here, and so that is the circuit here. Let us see the circuit here. So let us check if this is true. Let us see each one. We know that this is a buffer gate, no input, no lights. With input or push button, there's light. This is buffer gate, so it's a buffer gate. Here, inverter gates, normally no input with output. With input, 1 becomes off. So this inverter, this is OR gate. It should be either one of the two button is you push either one of the two, the LED will turn on because this is OR gate. See, it will turn on the output LED in this one, also turn on. If you both press the button, still turn on. That is the OR gate. Here, this is an AND gate. You need to push both the button to have an output here. So if you push just only one button or input one, still there's no light. Here also no light. If you push both the button, there's light here. You need to push both the button. That is a AND gate. And this one is NAND gate. You need to push both the button to turn off the LED. And because the truth table is this and the symbol of the NAND gate is this one. No output, still there is no input, there is an output. No input, there's still an output. So LED turns on. Here, no input, switch A and switch B with input. Still LED turns on. See, this is input of the switch B. Still with an input light, but still still with output light. With input light, the B, output light. How about this one, the other switch? See, still LED turns on. Still there is an output here, but we're going to press both and the LED turns off. That is NAND gate, and that is the truth table of the NAND gate. That is the symbol, switch A, B, and the output Y. So thank you for watching the video, and bye bye.